This video is mostly about angle pairs and figuring out whether or not they will be complementary, congruent, or supplementary. That's the most common stuff that can happen. So let's go with the basics. If two angles are complementary, that means they add up to 90 degrees. All right, hold on, technical difficulties. All right, so complementary means that they add up to 90 degrees. Congruent means that they are the same. So, which two angles are both complementary and congruent? They have to add up to 90 and they have to be the same. Do these add up to 90? Yes. Are they the same? No. So these, I'll throw this out because they are not congruent. Do these add up to 90? Yes, 45 plus 45 is 90. Are they the same? Yes, 45 and 45. So the answer is B. A silly person might have guessed C because they see the 90 and they think, oh, complementary means 90. But complementary means that the two angles add up to 90. These two angles add up to 180 because 90 plus 90 is equal to 180. These two angles are actually supplementary, not complementary. Problem number 2. Angle JEN. And what are vertical angles? Well, here's angle JEN right here, JEN. In fact, I'm going to go a step further and sort of color that angle in. So this is angle JEN. All right, so vertical angles should be directly across from each other. They sort of make an X. So what I like to do when I'm dealing with vertical angles is I like to extend the lines. So you see this line going to the left? To make the X, I need a line going to the right. See this side going sort of downhill? To make the X, I'm going to have to go in the opposite direction. So this red angle is going to be the vertical angle, which I will color that in as well. Okay, so these are the vertical angles. So angle JEN, that's the yellow one. And so now I want to name the red one. That'll either be KEM or MEK. I see KEM right here, so the answer is D. Again, complementary angles add up to 90. All right, so that is what we were looking for. A 90-degree angle is a right angle. So we are looking for two angles that sit inside of a right angle. That would make them complementary. So let's start with what they gave us, angle NEM. All right, so here is angle NEM right here, NEM. And I'm going to color that angle in yellow so you can see it better. So there's the first angle. Now we need another angle that sits inside of a right angle. Now here's the thing. I'm hoping that you can see that we have a right angle right here. All right, this is the right angle. You can tell because of the box next door. All right, this side is a right angle. That means this side has to be a right angle as well. So what is the other angle that sits inside this big old right angle? Well, the other angle is the one that I'm going to color blue. All right, this is the other angle. The blue angle is the answer. And that angle is the angle we can either call it LEM or MEL. All right, so I see it right here, LEM. LEM is the blue angle, so the answer is C. For number 4, NEM and what angle form a linear pair? A linear pair, that's two angles that form a straight line. So an example of a linear pair would be like this. Okay? Angle 1 and angle 2 would be a linear pair because they're back to back and they make a straight line. So that's what we're looking for. So just keep your eyes open. NEM. Okay, so here's NEM right here. Well, NEM. And again, I will color that in yellow just to make it even more clear what we're talking about. So that's the angle that we're given. But we need to make a straight line out of this. So the only way to make a straight line is to take this side and keep going with it. So if I continue with this red, can you see that this will make a straight line? And I need the angle that is back to back with the yellow angle. I'm going to color this one in blue again. All right, so this blue angle is the one that forms a linear pair. All right, the blue and the yellow together make the straight line. They gave us the yellow, they're asking us for the blue. And the name of this angle is either KEM or MEK. And I see MEK right here. So the answer is B. Okay, the marked angles are what? Let's see. These angles are exterior because look, this is the interior right here. Between the lines is interior. Everything outside the lines are exterior. So these are exterior, and because they are on opposite sides of the transversal line, they are alternate. So these are alternate exterior angles. So that means the answer is going to be A. Okay, number 6. These angles are called corresponding angles. And the way corresponding angles work is like this. Notice that this angle is in the upper right hand corner. And then I'll have another angle in the upper left hand corner. And I have a third angle in the lower left hand corner. And then I'll have a fourth angle in the lower right hand corner. Okay, so I could do the same pattern on this group of 4. And this is the lower right hand corner. And this is the upper right hand corner. And here's the upper left hand corner. And what was I doing? And this is the lower left hand corner. So this is what corresponding angles are. Each of these matching colors are corresponding angles. The yellows are corresponding, but also the blues and the greens and the reds are all corresponding because they're in the same position. But anyway, the answer to this particular question is C. All right, 5 is congruent to all of the marked angles except for what? Okay, well, here's what I like to do for these. I think it would be fun to make up a number and then see where it would go. So to me, this seems to be an acute angle. So let's imagine that this acute angle is 80. All right, imagine that angle 5 is 80. Let's look for all of the angles that would be 80. Well, angle 5 and angle 4 are vertical angles. So that means angle 4 would also be 80. Let's see, what else? Angle 4 and angle 3 are corresponding angles. Remember what we talked about? See the red angles right here? See how we have the lower right-hand corner and another lower right-hand corner? So can you see that's the same thing going on here? Lower right-hand corner, lower right-hand corner. These are corresponding angles, so they are going to be congruent as long as the lines are parallel. So that means this will also be 80. And then angle 1 and angle 3, these are vertical angles, so this will also be 80. So all of these are 80. Okay? So all of these are congruent. So let's see. So that means angle 5 is congruent to angle 4, angle 1, and angle 3. Angle 2 is the only one left out. So that means angle 2 is the answer. So B is the answer. All right, angle 5 is congruent to all of the angles except for angle 2. Okay, number 8. In this parallelogram, find the measure of angle HEG. Okay, HEG is going to be this angle right here. Okay, if I go from H to E to G. All right, that's the angle that we're looking for right there. So how can we find it? Well, let's start by finding this angle right here. If I make a Z out of this, it'll be a sideways Z, or maybe you prefer to think of it as an N. Either way, these would be alternate interior angles. So I know that these angles will be the same. They'll be congruent. So if I find one angle, I found both. And I'm noticing that we have 2 out of 3 angles in this triangle. All 3 angles have to add up to 180. So if I subtract the 2 angles I have from 180, I should be able to find the third. So I'm going to do 180, and I'm going to subtract 112, and I'm going to subtract 24. And that should give me the leftover angle of 44 degrees. All right, so that tells me the missing angle is 44 degrees, which means both of these angles are 44 degrees. So the answer is B. All right, what is up with problem number 9? I'm looking at you, problem number 9. I see we have a linear pair. These are going to be supplementary, all right? Together they make a straight line, like a semicircle. That's a total of 180 degrees. So these two have to add up to 180. So that's why I'm going to go 7x minus 21 plus 5x minus 3 is equal to 180. If I add these together, I'm going to get 13. I'm going to get 12x. And then if I do negative 21 and negative 3, that's going to be negative 24. So there I've combined like terms. It's equal to 180. Of course, now I need to add 24 to both sides. So that's going to give me 12x is equal to 100. Actually, this will be 204. 80 and 20, that would be 200. All right, so 204. And now I'm going to simply divide both sides by 12 and see what I get. $17. All right, and that's what we were supposed to do, is find the value of x. Okay. Now, angles like 1 and 2 are called alternate interior angles. Again, maybe you can see the sort of backwards z that's happening. The corners of this backwards z should be congruent as long as the lines are parallel. So angle 1 and angle 2 should be equal to each other. So I'm simply going to set these equal to each other. So that will give me 9x minus 80 is equal to 4x. Some students have trouble with this because if you were to subtract 4x from both sides, that's not going to leave anything over here. The way you handle that is by putting a 0. And then that would give you 5x minus 80 is equal to 0. And then you would add 80 to both sides, and you'd get 5x is equal to 80. And then you could divide both sides by 5. And that's going to be like 16. Okay, so the answer is going to be x equals 16. So that's one way that you could solve this equation. Another way, just to backtrack, because the 0, getting 0 on one side, some students don't know what to do with it, so they'll wind up just putting this, and then they don't know what to do. So sometimes it's better to subtract the 9x from both sides instead. So that would give you negative 80 is equal to negative 5x. And then when you divide both sides by negative 5, you're going to get x is equal to 16. All right, so that's how you do number 10. Looking at number 11, bisect. The word bisect means that it cuts in half. All right, so start with the second part. DF bisects angle CDE. Start by tracing angle CDE. So here's angle CDE right here. So this is the thing that is being bisected. This is what is being cut in half. So segment DF is the thing that's doing the cutting. So that means that the two sides will be equal. So this side should be equal to this side. Okay, that's true. But we have to be careful. Sometimes they'll give us a half and a half, but sometimes they'll give us a half and a whole. So we have to watch out and see which one they gave us. So let's see. CDF. In fact, now that I have given you the overall idea, let me go back. CDF is right here. Okay, CDF. That is CDF. Okay. Now, CDE. We'll do CDE in blue. Okay, so watch this. CDE overlaps this. CDE is the whole thing. CDE is shown here in blue. Okay, so did they give us a half and a half, or did they give us a half and a whole? I think you can see that what they gave us was a half and a whole. So when you have a half and a whole, here's what you have to do. 2 halves equals a whole. That is the model. So the half is the 4x plus 11. So I'm going to do 2 times a half is equal to the whole, which is 11x minus 17. To solve a problem like this, you have to do the distributive property, which will give you 8x plus 22 is equal to 11x minus 17. Now I see the variable on both sides, so I think I will subtract 8x from both sides. That will leave me with 22 is equal to 3x minus 17. Then when we add 17 to both sides, that will give me 3x is equal to, let's see, that's 39. And finally, I will have to divide both sides by 3. And I'm going to put this off to the side a little bit. Oh, well, actually, there's space right here. This will give me x is equal to 13. Okay, but now I need to find each of these expressions. So, CDF. Well, CDF is this expression right here, the 4x plus 11. Okay, so if I take that and I plug in 13, this will become 4 times 13 plus 11. Okay, so 4 times 13 plus 11. That's 63. All right, now CDE. That's the blue one. All right, but I'm now going to use purple. Okay, so I'll put that right here. So 11x minus 17 becomes 11 times 13 minus 17. And that's 126. All right, now remember that the first one was half. All right, we knew this from the beginning. The first one is half, and the second one is the whole. So keep that in your mind. All right, we know that this one is the half. Okay, that was this one that looks green at this point. But this one was the whole thing. That was the blue one. So it makes sense that 126 should be double the 63. But how about FDE? FDE is this angle over here. This is FDE right here. And hopefully you can see that FDE is the other half. So since it is also a half, all right, since this is also half, it should also be 63. All right, number 12. All right, so this is a parallelogram, so we'll keep that in mind. DF is 11x minus 2. So here's DF right here, by the way. This is DF. Okay, and that is 11x minus 2. Now, HD is 13x minus 10. HD is 13x minus 10. So here's HD right here in purple. How should the purple compare to the red? Well, the diagonals bisect each other. They cut each other in half. So these two halves should be equal. So that's why I should be able to solve these by simply setting them equal to each other. So I can say 11x minus 2 will equal 13x minus 10. Let us subtract 11x from both sides. That leaves negative 2 is equal to 2x minus 10. And then when we add 10 to both sides, we're going to get 8 is equal to 2x. And if we divide both sides by 2, we're going to get x is equal to 4. So fine, x is 4. Now, how about df? Remember that df is 11x minus 2. So that's going to be 11 times 4 minus 2, because x is 4. All right, 11 times 4 is 44. And 44 minus 2 is 42. So df is 42. Okay, so fine. That means this is 42. All right, next they ask me for HD. I could plug 4 into HD right there. But I am pretty confident that my answer for df is correct. So these should be equal. So if this is 42, then HD should also be 42. So I'm just going to go ahead and put 42 down. Now, what about HF? Well, I'm hoping you can see that HF is the whole thing. That's 42 plus 42. That's 84. So HF should be 84. Okay, let's see. Angle F is 8x plus 7. All right, so angle F is here. I just like to color coordinate as much as I can. Angle G is here. All right, so are these going to be congruent or will they be supplementary? These are going to be supplementary. In a parallelogram, opposite angles are congruent. So angle F and angle H would be congruent. All right, I would set these equal to each other. Angle G and angle E would be congruent. All right, these are across from each other, they are congruent. But angles that are side by side in a parallelogram, all right, consecutive angles, are supplementary. They have to add up to 180. So that's why I am looking for the equation that has the two expressions being added together and equaling 180. So that is B. Okay. Angle F is right here. Angle H, well, maybe I'll keep it like this for a second. Angle H is right here. These are opposite angles. They are going to be congruent. So I'm going to look for the equation that just sets these two expressions simply equal to each other. All right, and I see it right here. So the answer is going to be C. All right, now we're filling in the boxes. No work needs to be shown. Okay, so here's some stuff. Let's play around with it. Vertical angles are congruent. So I see the 124 on this side, so I'm going to have a 124 right here because these are vertical angles. All right, what's next? I have another pair of vertical angles right here. If this is 56, then this will be 56 right here. So that is feeling pretty good so far. What's next? Let's use the idea of the sum of the angles in a triangle. that always add up to 180. So I see that I have this angle, and all I'm missing is the third angle. So these three have to add up to 180. Let me clean this up a little bit. So I'm just going to subtract these two angles from 180 and find the missing angle. So let's see, 124, 33. Let's see if I can remember that. 124 minus 33. 23 is the missing angle. So that means this is going to be 23 right here. We can do something similar in this triangle over here if we wanted to. I've got the 81 and the 56. So let's subtract from 180. So let's do 180 minus 81 minus 56. That's 43. Okay, so I'm going to have a 43 happening right here. Let's see. Guess I haven't used this color yet. So I'm going to have a 43 right here. Okay, that's it for those two techniques. What I have to go to next is I'm going to start using alternate interior angles. And when I hunt for alternate interior angles, I'm going to draw Z's or N's, depending on how you look at it. Sometimes they will be sideways or backwards. But for example, can you see the Z that I'm tracing right now? Okay, the alternate interior angles are going to be the angles in the corner. So can you see that I've got the 23 is in the corner, one corner of the Z. So that means the other corner of the Z is also going to be 23. All right, alternate interior angles. All right, let's find another Z. For example, see the 33 in the corner? I could make a Z around that. So boom, all right, there, that puts the 33 in the corner. So if I complete the Z, you can see that the other corner is right here. So I'm going to have another 33 that's going to be right there. Whoops, that is a highlighter pen. So this should be 33. Okay, I feel like I can do that one more time. I see that this box right here is in a corner. So why don't I just make a Z around that and see where it leads? Okay, or you can think of it as an N, whatever you want. So if I make a Z shape or an N, whatever you want to call it, it's going to go like this. So this corner and this corner will be alternate interior angles. So if this is 43, then this should also be 43. Okay, I think we can do that again to find the final angle. So I'm going to now make a Z around this angle right here that I'm looking for. All right, so I put that Z, that missing angle in the corner, and then I complete the Z, and I see that those two should both be 81. All right, so that is going to be an 81. And that's it. We found them all. All right, the final question is a bonus problem, so let's get it. This is a parallelogram. EG is 3 times as long as FH. I feel like I should just write that down somewhere. Okay, so EG is 3 times as long as FH. All right, remember that. Let's see. So now we have DF and we have EG. EG sounds familiar. I was just talking about EG. All right, so EG, which, by the way, EG is this whole thing right here. That's EG, and there's EG. So that tells me that if I wanted to, I could put 14x minus 5 right here, because that is EG. Okay, now, I think it's time to look at the relationship between DF and FH. So look, here is DF right here. This is DF. Okay? Maybe I should color that. So there's DF right here. Now, what about FH? FH is the whole thing. Okay, so FH, maybe I should write this over here. FH is the whole. So what do we do when we have a half and we have a whole? We often will say to ourselves, okay, 2 halves equals a whole. And here we have a half and here we have a whole. So that means 2 times DF, all right, 2 times DF is going to equal the whole, which is FH. Okay. So, now look, we have an expression for DF, don't we? All right, DF is the 2x plus 1. And here I have DF right here. So we can use our 2 halves equals a whole to simplify this down a little bit. So let's see what happens. Okay, DF is 2x plus 1. So instead of DF, I'm now going to put 2x plus 1. Okay, and that should equal FH. With a little bit of a distributive property, I'm going to get 4x plus 2 is equal to FH. Well, guess what, guys? I now have an expression for FH. All right, look at this. FH is 4x plus 2. So here's FH right here. So look what I can do. I've got this 3. All right, so I can take all of this and I can substitute it in because FH is now 4x plus 2. So I can go ahead and put that in right here. 4x plus 2. And now I have an equation that I can solve. Another distributive property tells me that I will have 12x plus 6. And then meanwhile, on the left side, I still have 14x minus 5. All right, that looks better. So let's subtract 12x from both sides. So that's going to leave me with 2x minus 5 is equal to 6. And then if we add 5 to both sides, okay, that's going to give me 2x is equal to 11. And if I divide both sides by 2, I'm going to get x is equal to 5.5. All right, I'm just doing 11 divided by 2. Okay, so we're supposed to find the value of x and the length of FH. Did they give us lines to plug into? No. So we found the value of x. All right, so far so good. but now we're supposed to find the length of FH. But we remember FH is 4x plus 2. So that means FH should equal 4 times 5.5 plus 2. So that tells me that FH should equal 24. So these are the two answers that you should have come up with.